when we're talking about the key concept of the cloud, you have something that is cross cloud provider. So it could apply to AWS, to Google Cloud, to Alibaba Cloud, and stuff like that. What we are going to touch today are mainly those 5 topics: key concept and terms, difference between the CapEx and Opex model, difference between infrastructure as a service, platform as a services, serverless architecture, and software as a service, difference between public, private, and hybrid cloud, and then touch quickly around region and availability zones. I guess that the availability region and availability zone is something that is more Azure specific in a sense. Even AWS has this concept, but they might have different terminology and naming convention. Okay, now let's look into the first key concept. When we're talking about the cloud, what represents a cloud? What really is specific of a cloud? Cloud means that, in a nutshell, we are not having our own data center. We are not having to buy our own server. We are not going to have a network into our data center, but we pretty much, pass me the term. We are renting out someone else's computer. Now, how does it work? It works through a cloud management platform. So we log into a website where we have like some fancy buttons, some fancy links, whereby just by the click of the button, we can fire off a new server. We can fire up a new application and stuff like that. So it's not just the concept of having to rent someone else's place, but then we have also the options to easy provision application, provision databases, and stuff like that. And the level of provisioning depends then if you're just trying to rent out infrastructure, if you're renting out platforms, if you're renting out application and stuff like that. But we will see that in a few minutes. Now, what is important? Why everybody even after a few years now are still hype up about the cloud? First of all, because it has built-in high availability. What does it mean? It means that by design, you can potentially split your workload across multiple data centers. Therefore, if one data center by chance it kind of goes offline or there is an issue, you will potentially have no disruption to your end customer or to the application that you are using inside the organization, because there is another data center with an exact copy or the same application that is going to be kind of replicated. Now, this is actually a key concept to understand, because that doesn't mean that you do not need to plan for high availability in your design. It means that the option is there. But, for example, if I'm renting a Linux server into a data center placed in Dubai, if I do not have the same configuration into another region, for example, in US, I am not pretty much leveraging the high availability of the cloud. So the high availability there, but then it means that when we put together a cloud design, we need to leverage those components. So without cloud, to achieve high availability means that you physically need to build 2 data centers because they should be disconnected, and then you need to link those 2 data centers with fiber optics or high-speed internet, so that if one goes down, the other is still high available and stuff like that. Cloud is built by definition like that, because AWS has a lot of data center around the world. Therefore, it's built into their design. Then, what is instead scalability? Scalability is the fact that you can increase resources on the go. Often there are 2 concepts of scaling vertically and scaling horizontally. To make it simple, scaling vertically is pretty much when you are adding more RAM or more CPU to the same server. So if, for example, you have a website and does not have a lot of traffic, Now it's coming up Black Friday, so you are going to have a lot of promotion, and therefore you think that your server will be your website will generate a lot more traffic. So instead of switching off the server and reinstalling everything into a bigger server with the scalability vertical, you can pretty much increase the CPU and increase the RAM right away in that server. The second option, you have also the option to have the horizontal scaling. Horizontal scaling is when you pretty much increase the number of servers that are dedicated to the same application. This is typical, for example, for big data type of application like Cloudera or Informatica, where you can double up the number of servers or increase by 3, by 4, by 5. Therefore, the overall compute capacity is the sum of all the servers. Now, when you scale up or when you scale horizontally, depends on the type of application. Some application will allow you to split the workload through in multiple servers. Some instead they do not allow to do that. Therefore, the only option is to scale up. There are a couple of questions sometimes that ask you about if you want to scale up or scale vertically or scale horizontally, and that's what you should be able to describe or to know. Elasticity is the concept of being able to automatically or dynamically scale up, scale vertically, scale horizontal. In this case, how do you do that? You do that typically by including into your implementation some script or some event-driven actions where if they see the spike of the traffic going up, it means that automatically you can increase the RAM or the CPU and stuff like that. Is actually a very, very, very important concept because that's why cloud is one of the first probably reason of cloud being so successful, because especially as a startup where you might not have you might start with a 0 client and just a web presence. The more you get traffic, instead of just rethinking about the architecture or migrating into a bigger server like you will do in your own data center, you can just create those rules of elasticity and scalability, and therefore everything can be automatically increased or decreased. This is the typical example, as I mentioned before, is Black Friday, Christmas sale, Boxing Day sales, where pretty much what you do, you allow some parameters or some action to drive the need or not of more or less compute and or CPU, RAM, and memory and stuff like that. Agility is the fact that you can allocate or deallocate a lot of resources very quickly, and this is all built into the what I called before the management console of the cloud. In theory, if you have all server into your data center, you need someone, and if you do not have a management console, you need someone that physically go there and eventually open a server, include the extra RAM, physical RAM into the server and stuff like that. While if you have all the virtualization and all the management console, this can be done very fast and quick. Fault tolerance. Fault tolerance is pretty much when how do you identify a component that is not working and how can you restore from that. The fault tolerance and high availability are often kind of similar concept and sometimes confused. There are a couple of questions into the exam where they kind of ask you if one of the solution would be a high availability or fault tolerance. What we would like to highlight are those definitions that we are putting those red box. High availability, when it pretty much is the application, the server, the infrastructure can run long time without almost any downtime. Fault tolerance is pretty much avoiding that a component of an application, of an infrastructure, or a platform will no longer functioning. Disaster recovery. Disaster recovery is the opportunity to be able to come back from an unexpected downtime. Could be the fact that, for example, a data center as a electricity fault. How do I recover back? Well, that's by by having copies spread across the different data center of the cloud. So it's actually easy and simple to re-enable the data that was potentially lost into if one data center goes down. Global reach, it goes by itself. And it's because pretty much Azure, as much as AWS, as much as Google, have data center across the globe. Therefore, it's easy to be closer to your customer. Now, we know that cloud does not mean that you need to have all your server next to your operations or next to your customer, but and especially in a global economy like we are living now, you could have operation, for example, in Australia, but then you have customer in US. So how do you do that? Well, you have the option to have a website closer to your customer and providing services through the website closer to your customer while your operation can be still in Australia. So in that case, your typical cloud design will include different region and different zone around the overall architecture. Customer latency capability, which is actually very close concept to the global reach. So as I mentioned before, if you are hosting a website in Australia, but your customer are in US, by the moment that they click on a purchase item, and the moment that the transaction is processed could take a fraction of a second, while could be almost immediately if the server was placed in America. So for this reason, there are services that allow you to be faster and closer to your client. One of them is, for example, called Content Delivery Network, CDN, where pretty much you are replicating your website across different zones. And because you are replicating just a website, it's not like replicating the overall infrastructure components. Therefore, you can easy be closer to your customer and avoid some latency. For who is not technical, latency is pretty much the response time. So when you click on a button, when you click on a function, when you click on a link, how long does it take for the web page to get back to you with the result of that action? Predictive cost consideration. So because all those services, or almost all of them, they are based on consumption, we can actually know if a server will be up and running 24/7. We can actually know if we are running just a batch file at the end of the month for accounting reason. So we can easily predict the cost. Now, this the cost is we tend to say that is all on consumption. There are some components that are not really on consumption, because you can pretty much reserve a virtual machine for the next year, and therefore you have a fixed price, regardless you use it or not. But in the case, the advantage is because you have a big discount. And then last but not least is the security. So while the security here, we need to split into two different things. One is the physical security, and the other one is the cyber security. So from a physical security point of view, Azure take these very, very serious. In fact, it's not really clear where are those data center located. Of course, we know the region, but we don't know exactly the address of each one of them, and this to avoid any potential, physical security breach. Then all the people that are allowed inside the data center are screened. They need to go through some serious processes and stuff like that. Then this is for the physical security. So we are almost sure that non-authorized people cannot access those buildings, cannot access the physical server, and even if they access the physical server, the building, they still need to have special permission to access the server room and stuff like that. Then for what concerns that the cybersecurity, this is more something that is a shared responsibility between Azure and the customer itself. Any questions so far for those key concepts? Just to be clear, the certification will potentially ask some of those. We'll give you some example. We'll say, so how are we considering is an high availability scenario? This is definition of elasticity? So having an understanding of those concepts is actually important to ensure a successful of the exam. In a way that I described to you those concepts, it should be good enough to pass the exam. But again, let's be sure that we are across those terms and concepts.
Ivan, Nicola here. Sorry, short question. 2 points. You mentioned, okay, the network of the data that can be located everywhere, so there is no geographic limitation. The point why the client should have a benefit using global reach or latency response time that should be fast for research and something. So at the end, if I jump to the cloud, I don't care where the data are, or there are restrictions legally that some particular data should be stored somewhere. I don't know, patient data, for example, some country do not allow to save data in a particularly geographic places.
So yeah, no, a very valid point. So point number one is that you're right. Some of the client or some of the local regulation will not allow you to store data outside of your country. So point number one. But the most important thing is that let's think about an example. Think about Uber, where you pretty much have an app when you expect that by the click of the button, the app is going to be very fast and responsive. Therefore, an app like that need to locally run within your closest data center. So even if your operation is in US, then you need to replicate application layer and potentially even the data closer to your customer. So that's how the global reach and the latency is play an important role for us as to design application. Then instead, if you are just working with a government, and typically the government do not need to reach people outside of the country, or regulation will not allow you to store data of the government outside of the country. In the case you have just the reach of the country, but even within the country, you can still typically use multiple zone or multiple data center within the country to enhance the high availability, and also to be sure that you are ready for a disaster recovery.
But the second question, okay, thank you. The second question was, you mentioned virtual machine. What is it? What is it? A virtual machine? Is a server? Is a database or application? What is it?
So this is the difference between in a data center, you typically see a rack with a lot of what's called blade, and those blades are physical server, which means they have a motherboard, they have a CPU, and they have some RAM and some memory. That is a physical server. Now, typically, you do not have a one-to-one of physical server and application. In a sense, let's say that you have an application that need to run with some specific version of a Linux. Then you need to have an application that instead might maybe run on Windows. Then maybe you have an application that instead you need to run on a Red Hat distribution of Linux. In this scenario, typically you do not buy 3 physical servers, but you have what's called virtualization. So you pretty much, out of that one single server, you create 3 different virtual servers. They're called virtual servers because they're not hosting, they're not physical, but they're on top of one physical server. You can have multiple. They're called virtual machine or virtual server because they share the same hardware, but in reality they are separate environments. Now, to do so, you need a special software which is called hypervisor, which pretty much runs on the physical server. So you have an hypervisor, which is let's make this simple. The hypervisor is something that is similar to Windows, but with specific feature where you can pretty much start a virtual computer inside a physical computer. I don't know if it makes sense.
No, I remember that basically in some cases with the client, we had to access from our Accenture laptop to some data with Microsoft, for example, supporting Microsoft on the server of the client that they call virtual server, is the same concept?
But no, I think that what you're referring sounds more like a virtual network. Then whatever you access on the other side, it could be physical, it could be virtual. In reality, you don't know when you access a server if it's physical or virtual unless you are the one that is managing it. So think about that. On you purchase a box, and in technical terms, it's called bare metal. And in the box, you can kind of simulate multiple virtual boxes. So you have a physical box, like a big box container.
Yes.
From there, you can simulate like you are accessing actually seven different computers. Let's put it like that, or 10 different computers. So that's why they're called virtual, because they're not connected to, well, they're not one-to-one between the server and the bare metal box.
Okay, so I got an idea. Thank you.
I don't know if someone can help me out on this, give a better definition. But in a nutshell, you have two components. So let's say that tomorrow you wanna even in your laptop that you have from Accenture, this is a physical server, or you can call it computer or server. That's a physical computer. Now, within that computer, let's assume that you install Windows and Linux.
Yes.
Those two are virtual because it's not one-to-one between the installation and the physical computer.
But I share the same resources, the same CPU, the same memory, and the same platform, the same Wi-Fi, cable, blah, 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 all the things.
That's the point. You share the same physical resources.
Okay.
Okay?
Yeah. Thank you.
No problems. Any other questions?
Yeah, I have one question. Could you please again explain fault tolerance?
So the fault tolerance is how good is your system to avoid that a component is not functioning. For example, let's say that you have a hard drive that is not an SSD but is an HDD. Therefore, while spinning, it starts to not spin anymore. If that's happened, are your application going to be affected or not? If it is going to be affected, it means that you are not ready for fault tolerance. If you're not, it means that your system is smart enough to identify that hard drive is not working. He has a copy of the data somewhere else and swap over to the other hard drive that is working.
Okay, yeah, thank you.
No problem.
So, Ivan, Shan here.
Yeah.
Just quick question. So, what I understand, whatever you have mentioned, high availability, scalability, until security, as you use the word called leverage. So, in that terminology, if fault tolerance, as you just shared right now, so we need to leverage that, how we should avoid those things and leverage the concept what you have mentioned here as a best practice. Is that something you're talking about?
Yes. Those are concepts that pretty much the cloud that are the pillars of any cloud implementation of a cloud provider are on those components. What we really remember for the exam is that what each one of those terms means, and by that each question could be how do you enhance availability, or how do you avoid to not be ready for a disaster recovery. So you need to read the question and understand how those things could apply. But those are really the definition and understanding of the definition should be good enough to pass the exam.
Okay, thank you.
Welcome. Okay, next. Any other question, guys? Okay, perfect. If not, let's go to the next concept. Again, this first day session is really not much focused on Azure. what I like to say is that it's not that it's not focused on Azure, is that Azure tests you, Azure AZ-900 tests you on cloud basic concept. So those concepts are like cross cloud provider, and it's also good to that we have those concepts though. CapEx versus Opex. Now, if tomorrow there is a startup that is starting with a new online business and they don't have any server, what they need to do into the traditional CapEx world, they need to go out, purchase a server, purchase network appliance, purchase storage, purchase firewall, physical firewalls, and so on and so forth. What does it mean? It means that they need to allocate a lot of money and they need to spend a lot of money upfront. In this way, what's happened that in 6 months the startup is very successful, and their existing infrastructure, their existing server are not big enough. And by big enough, it means that the compute is not the server are not fast. When there is an overload into the internet traffic, the application might not respond well. They are running out of storage and stuff like that. Then 6 months down the track, they need to go back to the market, purchase another other server. And again, this is the same concept that I mentioned before into the scale up or scale horizontally. So they could potentially go and purchase a physical RAM and open the server and include extra RAM, and that will be a scale up. Or they may go out and purchase another server. So in the case, from one server, they have two servers, and that will be a scale horizontally. Now, this is a concept of CapEx, where you go out, you purchase hardware until it's not old or you require more, and then you need to purchase more. And then you need to purchase more. Now, the moment that you don't need this hardware, you cannot just go and take it back to the seller. Yeah, maybe you might try to sell it on eBay as a joke, but that's not something that businesses will do. Then they have also a problem. Let's look into this chart. In this composed period, you see that the red represent the capability or the cost of the capex. Then you have in the two blue and black line represent the demand. Demand in terms of resources, so RAM, memory, CPU, and stuff like that. Now, in this scenario, when the demand is higher than what I have, well, we have a problem. It means that our website will not be responsive because we will have too many people at the same time on the website. Therefore, some of them will get a non-response from the website, if not all of them, because it will be kind of not working that well. Now, the Opex auction, instead of being instead of basing our resources on what we have purchased, is actually renting those resources from someone that has purchased extra capacity. Now, and that's what I mentioned before. Cloud sometimes is seen as I'm going to rent some CPU, some RAM, some storage, some network, some firewall from someone. I don't even know where this storage is. Well, I might know that is in US North, US West, or Asia Pacific, but exactly I don't even know where they are, in which rack, in which server, and stuff like that, because you don't need to, you just rent it. Now, in this scenario, you can see that if I have an Opex model that follow the demand, and this is the perfect example of a cloud, I'm never going to be short of resources, because if you can see that the blue line follow the actual demand with a little bit of an extra capacity. What does it mean? Here in this case, I'm actually paying only up to the blue line. While if I need to increase my capex, I will have paid this extra capacity that is there sitting and not doing anything. So the capex. Sorry, guys. There's an echo. Sorry. So the capex versus Opex is not only a financial different model, but also with the cloud, allows you to follow more carefully the actual demand. So with the CapEx, you have the cost upfront and very, very little operational cost in terms of hardware and software. Of course, you have high operational costs for the people that will maintain the data center. So you have dedicated people that go there and ensure that the power is on, ensure that the server are updated with the latest patches, ensure that there is the antivirus is not running out, ensure that the storage is spinning, is there and is doing its things. Backup is another nightmare. If you are doing still backup on tapes, be sure that someone goes there and check the tapes and stuff like that. So the capex is very cost intensive on the overall investment upfront, as well as the operational cost to run then the data center. With the Opex instead, we are saying that the Opex, you kind of spend the money for what you are consuming, and especially with the cloud, you do not have upfront cost whatsoever, and you pay only for what you use it. Then all the operational costs, as I mentioned before, you don't even need to worry about, because they are those costs are kind of blended into your consumption rate. Therefore, you don't need to think about if the power is up and running. You don't need to think about to swap the tapes on the backups and stuff like that. This is actually one of the reasons why most of the company are moving towards the cloud, because they actually can spread their cost on the years instead of having just a massive investment at the start off their own data center. Any questions so far?
So this looks a reflection of your elasticity, what you talked before.
Correct. This the blue and black line is how the elasticity works. You just can cope with the different increase of demand, and also you're optimizing your cost and expenses. Now, in the long run, if you're talking about years after years, maybe the overall cost can exceed, but then you need to understand that cloud is not only saving cost. Actually, some of the time it's not about saving cost, but it's about flexibility and elasticity. And also you do not need to have in-house IT to manage the server, because that's something that is completely out of your landscape of skill set. Therefore, you can, like they say, you can be focused on doing business type of application. You can be focused on growing your skill set around area where it can really bring value to the organization, and not grow and not paying personnel or people or invest money on someone that just does a Windows server upgrade. So that's the big difference.
Ivan, this is Navina here. Apologies for joining the call very late. I had some technical issues. I want to ask a question which you may have answered because I did miss a bit. So looking at this diagram, then we say we pay for what we use. So would your operational expense then be your actual demand, which is the thin black line? Is that what your cost would be?
The cost will be the blue line, because you need to even if the actual demand is you pretty much have a little bit more of extra, because let's say that you predict your system is tuned up to be as close as possible to the actual demand, but then you have extra capacity to avoid some trouble, because let's say that you have I don't know, you foreseen to have 1,000 users on your website. Therefore, you might just run a virtual machine with two core. And then the moment that instead of being 1,000 or 1,500, the system will crash. So you, instead of provisioning a machine with 2 core, you will provision a machine with 4 cores, so just a bit higher. But in this case, instead if you are going for a capex, maybe you foreseen up to here. So you say, well, I need a machine for 8 cores, and the cost of a machine for 8 cores versus a 4 cores is not double, but almost. If you know what I mean. But
Yes.
pretty much we are very, very close to the actual demand.
Okay. Thank you very much.
No problem. Then I see here a question on the chat box say, an example to the customer latency. So the customer latency the latency is the concept of how fast is an application, a website that you are using. So if, for example, you are going on a shopping cart and you click pay, how fast do you get successfully payment? So the more time you spend on waiting, the more latencies you have. So to reduce this latency, there are multiple ways. For example, with the cloud, you replicate application layer across the world. So if your operation again are in I don't know, in Australia, you need to provide customer with services in America, instead of them to come to when they click pay to get that payment from the mobile phone in US all the way to Australia. You can replicate the application layer in US, so that when the customer in US click pay, the process of the application that process the payment can run in America. So for the customer, the experience will be better and faster. I don't know if that makes sense for the customer latency capability. I guess it is. Okay, next one. Describe infrastructure as a service, platform as a service, serverless, and software as a services. Now, I'm pretty sure that all of you have heard this term before. I'm not too sure how much are clear, but not clear in terms of what they mean, but clear in terms of what is the difference between all of them. But let's quickly go through. So the infrastructure as a service is when pretty much you are renting out from a cloud provider everything that is infrastructure related. So the virtual machine, as we mentioned before, the storage, the network, and the operation system. That's all we need to ask to be considered infrastructure as a services. Now, when we do infrastructure as a services, is important to understand that all the components that we mentioned before, for example, high availability, if you purchase an infrastructure as a services, you need to build the high availability on top of the Azure data center. What does it mean? If you request a virtual machine, and this only one virtual machine, and this virtual machine sits into one and only zone, you're actually not doing any high availability design. To do that, you need to replicate the same machine into another zone, so that in case one zone goes down, the second zone step up. And in this case, we are going to in high availability. Of course, the high availability concept is a bit more complex than what I explained to you guys now, because you can have active, passive, and so on. But in a nutshell, the infrastructure as a service is the most simple way to fire off cloud. Is probably the way that most of your customer will experiment with cloud, because it's just simple to create an account, go there, and create a virtual machine. Then what typically the journey from on-premises to a cloud goes through infrastructure as a service, and this is where you start a virtual machine and start to move across some of your application. So you have a few applications that you might want to test into the cloud. You move them across to the cloud, and then you see, and that is your pretty much your first step. Now we need to ensure that here, for example, in the infrastructure as a service, operation systems are provided, but they're not managed. What does it mean? If Windows has a new patch release because of a security breach, it's up to you as a customer to do the upgrade. Azure will provide to you the compute power, pretty much what into the infrastructure as a service. Azure provide you the first three blocks into this picture. The data center, physical, plant, and building. What does it mean? There is a physical building with power, supply with cooling down system, because cooling is very important to not have burn everything on hot weathers. Security, physical security, so gates, badges for people to walk in and stuff like that. Then it provides you a network firewall security. In this case, what it's providing you is the network and firewall security to access the cloud, but not to secure your instance. It's up to you, because you cannot secure your instance, avoid the secure instance, because Azure is providing you network and security. Then it provides you compute, storage. Now, on top of that, it's up to you to build which operation system you want to put. You want to put Linux, you want to put Windows, you want to put a Red Hat distribution of Linux, Oracle, you name it. On top of that, it's up to you to develop an application, put a database, stuff like that, and or host all the different things. So infrastructure as a service, by definition, is pretty much a cloud provider giving you a space into their data center, and the space can most of the time is virtual. Is not, you are not access of a physical blocks, but it's just a virtual machine. And this virtual machine is up to you how you want to handle and manage it. Now, the cool things about the cloud is that you do not need actually to be physically close to this machine to manage it. How do you manage it? Through the internet, through this cloud management console that I was mentioning before. And Azure is pretty much is the place that you are going to do that. The definition includes the IaaS. Well, what typically they provide you as an infrastructure as a service? They provide you the the operation system, but it's up to you to manage it. What does it mean? If you install, for example, Windows Server 2020, and if there is a new patch or a new security breach that needs to be updated, it's up to you to update that. It's not going to be done by Microsoft. For example, is just a quick. You have a few example into the Microsoft website. The docs.microsoft.com is actually a good place to go and look for different design docs. It show you, for example, how there is a connection between the on-premises application and what you can do on the cloud. As you can see, you have all those components that are kind of, for example, the gateway is not a physical gateway, it's a virtual gateway. You will have a virtual firewall, and then you have different components. This is pretty much just to show you that within the infrastructure as a services, the network components are the one that you are going to get as an infrastructure as a services. So in this case, what's called here is called virtual network, as you can see here. And the virtual network is composed by multiple components, such as gateway, firewall, the subnet, and all the other are just subnet. What is a subnet? A subnet is a way that you are segregating the different resources into segregation of bucket of resources to better manage and access and manage the control of the network.
So basically in this chart, you want to tell us that basically me as a customer, I can take a piece of infrastructure, I can rent infrastructure from Azure, for example. So server, RAM, data storage, whatever, then that I can access with my application. I can use with my application. It's up to me to maintain the application, Windows, Linux, whatever software I will run operationally into this space. And with the virtual network, I can connect in this virtual machine some other applications that are on-prem. It's this more or less the nutshell.
This is more or less the of this diagram. But what is important to understand is that if you go back to the previous slide, the infrastructure as a service comes with the network components, and this is pretty much telling you what are the network components that you get. Of course, those you comes with, it doesn't mean it's free, because you pay for the gateway, you pay for the firewall, you pay for the subnets. But then in a nutshell, it tells you, well, this is your Azure environment, and somehow you connect to the on-premises environment as well, and you can have interaction between the two. But that's kind of a concept of a hybrid cloud that we are going to see later. What's important for this specific topic?
This can be applicable for SAP, for example. Can I have my SAP S4? I can rent infrastructure from Azure, all infrastructure, and I use this to run my SAP S4HANA. And then
yes, it is applicable. In fact, there is I think it's an offering which is called Hack of SAP, which actually run on Azure. Absolutely applicable.
Okay, so yes, SAP can utilize the infrastructure of Azure, yes. But the cloud platform is on SAP. Is a SAP solution.
The cloud platform is on SAP.
But the infrastructure, the physical infrastructure, the data center below can belong to another provider.
And well, no, in this case, we are so SAP. I'm not 100% sure. I know that there is an offering of SAP on Azure. I'm not too sure if SAP also have their own cloud offering where they're running their own data center. So in the case will be.
No, they have. SAP has own data center. So SAP can offer cloud solution, so a cloud space platform.
Yeah.
But the infrastructure below either can be SAP, so data center, or I don't know, memory, CPU belonging to SAP, or SAP can utilize data center or infrastructure from another provider.
Yes, absolutely. That's a good statement, and I'm sure because I've been involved into a proposal where we were proposing SAP on top of Azure, so I'm pretty sure that that's definitely an option.
Okay.
Perfect.
Thank you.
Ivan?
Yeah.
Ivan, if you go two slides back, just to be clear, if I were to be asked the question in the exam, what does IaaS provide? What would be the correct answer? On the left, we would say infrastructure services, virtual machine storage, networks, and operating systems. On the right, we would say data center, physical plant building, networking, firewalls and security, service and storage. What would be the right answer if we were asked the question in the exam? Would it include or exclude operating systems? Sorry to harp on this, but I need to be clear in my head.
So the concept of it includes operation system, but don't include the management of the operation system. Let me explain to you. You cannot go on Azure and request a compute, RAM, and storage without telling them which operation system do you want them on. So it includes, but what is important to understand is that it does not include the management. So if you need to upgrade the operation system, if you need to include a patch, is not what you want. So yeah, probably you're right. Maybe this picture should include that operation system as well.
So I do understand what you're saying. I understand what you're saying, and it makes sense. But if we are asked in the exam multiple choice questions, where we cannot input, where we can't capture a comment that says it excludes the management of the operating systems.
I would say include.
Okay, thank you.
Welcome. Now,
I have one question about what is DMZ, the full form of that.
I cannot say it. It's pretty much the
demilitarized zone.
Day-1.
Demilitarized zone. Okay.
Yeah. It means pretty much is a term into the security that allow you to keep a zone of the internet safer. So it means that you build all these things to have a safe zone where you can interact with. So
yeah, I mean, I knew demilitarized zone because I did not think that it had the same meaning here.
Sorry. Okay, now let's go to the next one. Platform as a service. Platform as a service could include infrastructure as a service plus some development tools, database management, and business analytics. So what does it mean? It means that you are a platform as a service, you pay a subscription, and the difference, just to go back to the infrastructure as a service, is that you don't care about the operation system here. You don't even interact with the operation system, and you don't even need to upgrade the operation system into a new version or the patches or everything. But you are up to here, and what you do here is pretty much build something on top. Typical example of the platform as a service is a SQL Server purchased not as a license but as a platform. Typical example of platform as a service is for example, the option to have there is for example in Azure there is an IoT platform that allow you to connect IoT devices where you will pretty much they read the feed of the data, and then you can build on top of that. So in this case you have a platform of development. Typical platform as a service is also development tools, DevOps, and stuff like that. Now, why is it important to have these components? Is because in this case, for example, because of the type of responsibility of Azure, you do not need to foresee the high availability because they're already doing availability for you. They're already having 2, 3, 4 redundancy of server and as many as they need, as many as they want, in order to be sure that this is always up and running. They know that you don't need to look into the scalability or elasticity because they are already fetching this according to how you are utilizing their platform. So that's why this is kind of reduced even so you don't have the flexibility, for example, to install the version of Linux that you want or upgrade or downgrade the operation system because you do not own that. But the same because it's done for you, same as the infrastructure in terms of redundancy. So here is pretty much a way where you can rent an application, a platform, and build on top of it. Typically, our database are AI type of platforms, Internet of Things, and stuff like that. And we can see quickly later what are the typical platform that Azure has. In fact, here we can see what are the platform. Those are names that are Azure specific. Now, I don't ask you to remember them all, but maybe browse those things and try to understand what they do. Because, for example, here you can see infrastructure as a service, the bottom line. Actually, this is actually a good picture because the bottom, it tells you the physical server. You can see that those are like physical boxes. On top of the physical boxes, you have infrastructure as a service, which is virtual machine, containers. I don't know if you guys are familiar with containers, or we can speak about that later. You have storage, and within Azure, you have different type of storage, like blob, queue, files, disk, and so on and so forth. Networking components, so virtual network, load balancer, DNS, stuff like that. So those are all components of Azure in the infrastructure as a service. Now, when we go into platform as a service, as I mentioned before, you have different platforms as a services. For example, in terms of media and content delivery network. So service media, media analytics, content delivery network. What is this? Those are platform or where you can build on top to stream media. You want to have you want to build a competitor of YouTube? Well, probably you will go here and create something out of this platform. Integration is another great example of a platform. You wanna, for example, have some API management. Well, the API typically are one of the components of the integration. Azure allow you to build on top of their API. What does it mean? It means that you do not need to buy a box, install an operation system, define the storage, set up the network, and then install an application to deal with API. They just give you the API as a platform, therefore you just build on top of that. And so on and so forth for all those different services that you can see in this slide. Any questions so far?
Ivan, Nicola here again. So when we mention platform, means that the famous app that Azure provide, I don't know, apps for machine learning, app for analytics, power of, there is one that is very famous, power of something for the finance, in the finance space. This will mean that I need to take one of these platforms in order to get the apps working. No?
Not really, because what you are describing sounds more like a software as a service, where you pretty much pay a subscription to the software, which is the next level up. So the platform is when you buy something that is there for you to build on top. For example,
so in this platform, I can develop my apps or
Correct.
my application.
Correct.
So I get only the space. And then it's up to me to define the concept, which data I need to elaborate, how to export, blah, blah, blah.
Yeah, because
it's not something.
Yeah, because maybe your platform requires some API integration. Maybe your platform requires some, I don't know, a mobile component. Maybe your platform has your end application. Sorry, your end application maybe needs some to integrate it with API with other components. As a component of mobile app, as a component that will be on Cosmo DB, and maybe another component that is in SQL database. So you build your app putting together those platforms components. While instead, if you're thinking about that, you're renting an application which is already there, ready for you to use, and all you need to do is just pay a fee. You go, You go into software as a service. A typical example of software as a service is Salesforce. You don't know where Salesforce run. You don't even need to know where Salesforce run. You don't need to build anything on top of run. You just pay a subscription and you use it. Another example of a software as a service is Office 365. You actually don't know if when you store your document in OneDrive and then you open your Word, you don't know where those software run. They could be in the data center next to you. They could be replicated in a data center in US. And this is the difference between the platform and the software as a services. The platform will give you a development environment to build your own application. The software as a service is that you have an application where you just pay a subscription. Typically is for user base, but not necessarily. There might be like annual fee and stuff like that. And then you just need to use it. Of course, there might be some fine tuning here and there, but it's not development. It's more about configuration. I don't know if it makes sense, the difference.
Okay, so when I use basically SAS application, I don't need to care about all the infrastructure connection. It's something that is already predefined in the application. So I don't need to manage the network, for example, or the latency, for example, because it's something that is insured in the application when I pay the prescription.
Correct. The definition is, the example are emails, calendars, office tools such as Office 365 or Dynamics CRM. So in the case you don't really know where your email is hosted, when you purchase Office 365 and it comes with the Outlook, you don't know where email is stored, and you don't even need to know because you're not going to manage that level of infrastructure. Microsoft does that for you. So
okay,
perfect.
And when I migrate my SAP application, so S4, so on the on-prem, so basically it's my private. This will be a PaaS, right? Because the cloud will provide to me only the platform, but software is on me, modification is on me, maintenance is on me, and so on. We'll provide only the platform to connect, I don't know, with the external system. Maybe if you go back to the blue, yeah. So integration component, or I don't know, IoT in case I have external tool that basically need to take data, I need to save data somewhere. So in the platform. So we move from the case that we discussed before when we say hack, so that SAP can take the space on another data center, and this would be AIS, to the PAS when basically I have on my platform, on my cloud. It's something that like this.
Yes, partially no, because if you have an application that is on premises, probably the easiest way is to just get the infrastructure and you just reinstall everything in the cloud. So the migration path typically does not go from an application that you have on premises into a platform, because platform is when you want to develop on top. I assume that the platform is not a connector. It's something that when you want to develop on top. Let's say that you want to do an app that have a mobile app component, then the app need to through API to connect to a bank system, and then store data into Cosmos. That's when you use a platform. When you need to build something really from ground up. In the case that you described to me, what I would do, I would just get the infrastructure as a service where I pretty much provision 2, 3, 4, 5, 72 different servers according to my design, and then I install the application that used to be installed on premises into the cloud, and that's how I would do it.
Okay. Yes. Makes sense? Then I can connect the two things. So when I put my S4 on the yes, I made a mistake. Makes sense. What you say, absolutely. So when I put my on-prem on the IaaS, so I rent the infrastructure. In Azure, this is possible that my S4 can dialogue, can talk without some of the app that I can build in IoT platform or on the, I don't know, on the data. Is something that is native that can happen, or I should buy something else?
But no, that depends on the overall architecture, because let's say that you have an application which is SAP that you are running into your data center. Then let's say that you want to move that into a cloud, and therefore maybe you just fire up some infrastructure. And you do not want to go to SAP HANA. You do not want to go to their you say, first of all, disclaimer, I don't even know if you can do it. Because maybe the licensing does not allow you to run it on the cloud. I don't know. I'm just guessing because I'm not from India. But assume that you can do it. You will fire off some server, some virtual machine, and you configure the network. Then I will install on top of that operation system the SAP, the SAP. Then I will need to create probably a database somewhere and stuff like that. Now, if on top of that you need to create an application, which is a completely custom built application, you have an option to, number one, again, provision another server and build up all the ground up layer, or use one of the platform. API management is just a server that Azure gives you, where they have already installed an operation system, they have already installed some storage, and they already put there some development tool for API. But nobody stop you to rebuild the same things by yourself. If you have the skill set, if you have the knowledge, or if that's work better for your architecture.
Okay.
So this is pretty much is a way that you can accelerate your development, because they give you some, it's like having Lego bricks, and you have already some Lego bricks ready for you. And then you build on top of those Lego bricks. You have the foundation for something that is already there. We already spoke about the software as a service. Here is a kind of a good summary for the management responsibility between on-premises, infrastructure as a services, platform as a services, and software as a services. Now, as a management responsibility, I think that this picture should be clear to all of us. So if we go up from the bottom up, and we go from the networking, the storage, the servers, and the virtualization, the operation system, the middleware, which are all the level of application that typically will be into the platform as a services, the runtime, which is when you run an application, so the library, all the information that are needed to run an application, the application itself, and the data. Now, the management, you can see that goes from everything on you as a customer and everything to Azure as the provider, goes from on-premises, infrastructure as a services, platform as a services, and software as a services. I think we can, unless there is no question, we have already touched all of those elements probably in the previous slide, just for trying to make up some time. If there is not any question, I just skip to the next slide. Difference between public, private, and hybrid cloud. So public cloud is what we typically see with Azure, AWS, Google, Alibaba Cloud, and stuff like that. It's pretty much a cloud which is accessible through the internet. Everybody can join. Of course, they can join as an individual account, but it's not that they can join into my account. It's self-service, and it provides resources through an internet connection. So you, in a public cloud, you do not technically need to know how many boxes are behind the cloud, where are the boxes, and all those kind of questions. You just subscribe. You have an account, you have a management console, and you can just fire off services pretty much immediately. The private cloud instead is a concept of a cloud but is into your data center or into a private data center. Now, why is called private cloud and not just a data center? Because it's an old style data center, but with the management console very similar to the cloud. Azure has a server that you can install into your data center, which are called Azure Stack. What does it mean? You install those servers into your data center. You have a management console, which is very similar to the one that you have on the public cloud, and allow you to provision server within your own data server in the same way. So you simplify a lot of the management with this option. Now, why there is the need of private cloud? Private cloud are very much needed for government organization. Government will never put their data into a public, or typically will not put data into a public cloud. So the private cloud is a way to emulate a cloud into your private environment. So typically, the access could be through internet, but most of the time is banned. So you need to have a private network, or you need to be physically within the distance of the cloud as well. Why that? Because of security reason. What is important to understand is that at least in the region, I'm currently in Dubai, so in the Middle East. So in this region, the private cloud is a reality, especially because the government really do not want to share their data into public cloud. All the different cloud providers, Azure included, as I mentioned before, they have a different way to develop the private cloud. Saying that, there are also other providers such as HPE. We have our own Accenture hybrid cloud solution, where we can pretty much go to the cloud, go to the client and say, okay, you are not comfortable to have your application, your data into the private cloud, into a public cloud. I can actually make this happen for you and have the same experience. So for you, you can fire off the application and the platform in a matter of a couple of clicks. What is the downside of this? Well, because you have your own private cloud, you need, first of all, a CapEx investment, because yes, it's a cloud concept, but you still need to have the whole all the server, all the licensing, the power, the cooling system, the facility management. So big CapEx. And also on top of that, you need to retain people and expertise to do the maintenance once it is in operation. So people that can update servers, people that can use and be very familiar with virtualization software. For example, VMware is one of them. VMware, Microsoft Hyper-V, and stuff like that. So that they can pretty much simulate all the virtual machine within your own private cloud. Third option, which is actually becoming more and more important, is the hybrid cloud. What is a hybrid cloud? Well, it's a mix of the two. You will have some application running into the public cloud, some into your private cloud, and there is mechanism to connect the two in terms of virtual private network, VPN, firewalls, and stuff like that, so that everything is kind of all secured. Now, hybrid cloud, to be honest, it seems to be a reality, especially because you want to leverage the best of both. One, data ownership and security, being in a private cloud. Two, cost optimization, operational cost versus capex, and global presence for the private cloud. Okay, next one again is a summary, as I mentioned to you before. Public cloud, no capex, agility, consumption-based model. Private is control and security. Hybrid, flexibility and compliance. Any question on private versus hybrid versus public?